Okay, so in this video, we're going to have a look at using the tangent ratio. We've had a look at how we can use trigonometry to work out the size of a side we don't know. In a right angle triangle, we can use it to work out the angle in one of the angles in the triangle. We're going to keep mixing that up now because it's important not just to keep repeating one type of calculation, but to be able to use the correct approach, whether it's a side or an angle, mixed up. And we're going to double that up with looking at how we can actually use trigonometry and right angles in shapes that maybe don't start off as right angled triangles. In other words, we kind of need to find where the right angles are. Let's have a look at this example here. It says calculate the height of this triangle. There's the height is in a triangle is the distance from the top vertex down to the base. We always know that the height is at right angles. So that's an interesting start. So what we can do is in this triangle we can notice that the dotted line makes a right angle with the base. It says calculate the height of this triangle. You notice in the diagram there's these two little dashes. That tells us that these two lines are exactly the same size, which means we're dealing with an isosceles triangle. And that's important because it means that this height here is also the line of symmetry. It tells me various things. It tells me that the two angles here, 76, is also this angle here, 76, but I'm not going to use that just now. But what it does tell me is that because this is a line of symmetry, that dotted line actually cuts the isosceles triangle up into two absolutely identical triangles, what we call congruent triangles. So in actual fact, I've got two right angle triangles. What I'm going to do is actually I'm going to redraw half of the triangle. Sometimes it helps when you do it that way. Okay, so what I'm going to do is just very quickly, I'm going to draw a bit of, let's do the left one. Okay, so I'm going to draw just half of it. And you can see here, there's a right angle. It's almost exactly right, a wee bit sticking out. So here's the right angle, like that. This dotted line, the height h, is now this side here, is h. Okay. We've got 76 degrees in there, so we can write in 76 degrees. And now we've got 35 centimetres all along the base. Now, if we're splitting this isosceles triangle into two equal parts, then it stands to reason that these two parts of the line, where the line cuts, are also going to be equal. In other words, the left-hand part here, I just highlight it, I'm looking at this part here. That has to be half of 35, which is 17 and a half. So a wee bit of working out. Sometimes you've got to work out some bits first of all. This is 17.5 centimetres. Okay, I'll write that in 17 and a half centimetres. So now we've got a right angled triangle. We don't know this value h. We know the angle is 76 degrees and we know that that base is 17.5. What I can do is I can start to see if I can use my tangent ratio. There, it's there in the top corner. So there's the side opposite the right angle is the hypotenuse. The side opposite 76 is the opposite, and the other side is the adjacent. So what have I got to work with here? I've got the opposite. I want to know the opposite is the adjacent. So I can use the tangent ratio. I'm going to write it out at the side. So I'm going to write out tan x equals opposite divided by adjacent. Okay. Always, there's three things we need to substitute in. X is the angle, which in this case is 76 degrees. The opposite side is the side we've marked h, and the adjacent side is the side we've marked 17.5. So now we've got to just think of what we've got here. It could have been an angle, it could have been a denominator, it could be the numerator. We've got to remember all these different strategies that we've learned. What do we do? Well, in this case, we're dividing by 17.5. So to get rid of the fraction, we have to multiply both sides by 17.5. That gives me 17.5 times tan of 76 equals h, because remember they cancel out. And that's all I need to do. On my calculator, I'll switch it around. H is equal to 17.5 multiplied by the tan of 76. 17.5 multiplied by, press the tan button, 76 degrees. I get 70.1886. 70.1886. Again, let's just cut it at one decimal place. That's 70.1. Round up, says the 8. And that gives me 70.2. And now, it says calculate the height of the triangle. I've put an h in to help me. So let's always, when there's a kind of word problem or where there's an actual size to put in or an explanation, let's put in the word height. Okay, so we can say height of the triangle equals 70.2 centimeters are my units, and I've rounded my answer to one decimal place. Okay, so there's my solution. I've created a right angled triangle from an isosceles triangle because of a particular property that says that height line cuts into two equal parts. Okay, let's have a look at second example. What does it say? It says in this rectangle, calculate the size of the angle marked x. Okay, so we're told it's a rectangle, which is kind of important in one way, because if it's a rectangle, all these angles are right angled. Those two in particular, but also the other two. Okay, all of them are right angled, but we're kind of not looking for the whole angle up here. We're just looking for the size of x. But the point about these right angles is that, yet again, if we take a dotted line as I've got here and draw all the way down from corner to corner, we've made two identical or congruent right angled triangles. That's great. If it helps, and sometimes it does, some people find it does, just copy one of them out. Okay, I'm going to just take this one. And the reason why is sometimes it helps to just focus what are the numbers that I've got and where do they go. Okay, so it helps me to think about it by redrawing it. So there's my right angle, and I've got x here, and I've got 26 millimeters. I could have, with all the space that I've got, I could have drawn it a wee bit further away. One of the things that we're rewriting it that you sometimes miss when you're looking at it is, do you notice that that's millimeters and that's centimeters? We're going to have to sort that out, because when we use our trigonometry ratio, they've got to be in the same units. So it doesn't matter if you make them both centimeters or make them both millimeters, they've got to be the same. So I'm going to make that 73 millimeters. Okay, so that's me kind of ready. I've got all my bits and pieces. So let's name the sides. And I was adjacent. So I've got the opposite and adjacent to put into my formula, which says that tan x equals opposite divided by adjacent. So put in all my numbers. X this time is x. Okay, so that's the thing we're trying to work out. Opposite side on my diagram is 73. Adjacent is 26. Now again, this is where we're mixing them up. This is different from the last question. You've got to remember what to do when you're trying to find the angle. So, well, we know both of the numbers in the fraction, so we go and work that out. So 73 divided by 26 is 2.8076. 2.8076, and so on. Remember that when we're rounding for the trig ratio, when we're at this point, try and round it to 3 decimal places. It's not the answer, so we need to keep it as exact as we can. So I'm going to use tan x equals 2.8. Whoa. Tan x, what should it be? 2.80. Well, the 6 says round up, so it's got to be 2.808. Okay. Now again, this is different from the other one. We've got to work back. We've got to get rid of the tan here. So this is the type of question where we're going to use inverse tan. And that's when we use our shift button on the calculator. Hopefully you remember practicing that in the previous questions. Shift tan 2.808, and I get 70.397. 70.397, and that's in degrees. Let's cut it to one decimal place. 70 point, cut it at the 9. 9 says round up, so 3 becomes 4. And it just says calculate the size of angle marked X. There's no words to describe it, so I'm just going to keep it as X equals 70.4 degrees to one decimal place. Okay, so here's two examples where we've started off with a shape that's not a right angled triangle, but we've managed to find right angled triangles in them to be able to apply trigonometry using the tangent ratio. Okay, so practice these types of questions and make sure that you understand how we can use it. Okay, hope that's been helpful.